What's poppin', dogs? Mr. Allen here working with some vectors in this video. We got to use these vectors to find the information below. So I got 4 different vectors, 2 questions. We're only using 2 of them here, but there's more videos to come. Don't you worry. We want the angle of direction of vector B here, which is our 7, comma, negative 24. Interesting. Wonder how I might go about that. Well, how about this? Let's sketch a little picture, right? Let's draw a picture. We got 7, then 24, so we're going to be in that 4th quadrant, if you will. So over 7 down 24, something like this, right? And let's label that. This is negative 24. This is 7. That's going to be a right angle, right triangle. All right. I want the angle of direction, right? So I'm looking for this maybe angle right here, okay? So how might we get that? Well, I got an idea. My old friend, trigonometry, right? If I've got 2 sides of a right triangle, I could use tangent inverse of the opposite, negative 24, over the adjacent positive 7. So there's 2 ways you can really plug this in my opinion. All right, now we could do second tangent of negative 24 divided by 7. Hopefully I am in degree mode. Let's find out. I am indeed in degree mode. And if you're ever worried, you're like, is that right? Is that wrong? Boom, look at that. Arrow down, degree, good to go. All right. So here I got negative 73.74. Okay. So negative 73. So we'll say theta, I guess, equals negative 73.739. So 74. And if we were doing 3 decimals, it would still be 740 because that 9 would get rounded up by that 7. So that's a fantastic answer. Another answer would be if we went all the way around. So coterminal to that one there. And that might be necessary if they say that the angle has to be between 0 and 360. So what we could do here, okay, so I could do 360 and then we could subtract that one, or I guess it's negative, right? So I should like add it to it. And I feel like sometimes that gets a little bit confusing. It's easy to get lost in the mathematical sauce. So what I like to do is this, okay? Not everybody does this. This is what I do. It's my video, so I get to do it. All right. I like to do tangent inverse of just 24 over 7. I ignore the negatives and positives in here when I plug it into my calculator. I get the answer. That's my reference angle, right? And now based on where my triangle is drawn or what quadrant, where it is exactly, I can use that information with what I know about angles of rotation back to, your other trigonometry units to get my answer. I know I got to go 360 minus that. So 360 minus this guy right here. Yo-ro. Arrow up. Get it? You only run once. Right? Arrow up. Enter. It subtracts it. So another acceptable here would be 286. Yeah. 0.26. Cool. So a few different ways to get that. Again, they may give you restrictions that it's got to be between 0 and 360. If so, you can either do the first thing that I did or just get your reference that's positive and position it accordingly. All right? Lovely. Fantastic and wonderful. All right. I think that's all I want to talk about on that one. Yeah, let's go with that. Okay. Now let's go to polar form. Actually, I'm going to go green on this one. So we want polar form of A. Okay. Now polar form, if you don't remember, is r comma theta. So let's keep that in mind, okay? Need a radius. I need an angle. We just figured out an angle, didn't we? Why don't we do that again, right? We'll do that again with this one here. And this is really where, in my opinion, it's helpful to work with your reference angle, okay? So if I draw this up, a little rough sketch here, it's negative, negative. So it's negative 5, negative 12. It's going to be looking like that. Whoop. Negative 5, negative 12. Okay. So if I want to find out that angle, right, I can do tangent inverse. Once again, tangent inverse of, and I'm just going to do 5 over 12. It's going to turn positive anyways, right? Negative over negative is positive. So let's do that. We're going to get ourselves our reference angle. It's going to give us the angle that is in the first quadrant here because it is positive and tangent's positive in the first and in the third. Our calculator is not going to give us that third quadrant angle. We got to use our brain skis here to figure out that third. Oh my God, I just did that wrong. Hold on. So now I can use So now we can use our tangent. So now we just use tangent inverse of my opposite over my adjacent once again. So negative 12 over negative 5 or just 12 over 5, right? It's going to turn positive. And honestly, regardless, like I've been saying, regardless if one is positive or the other's positive or they're both negative or whatever, I just do positive numbers here because that's going to give me my reference angle in that first quadrant. Use my brain, position it accordingly. So second tangent of 12 divided by 5, enter, we get 67.380 degrees. That's over here, right, in the first. So how do I get all the way around here? Well, I got 180 plus that angle, so let's add 180 to it. Leaving it all in the calculator. YOLO, you only run once. And I end up with my angle, theta, okay, so this was right here, 67.380, So theta, 247.3801. 380 and change. Cool, I've got the theta part, right? How do I get my radius? Pythag. And look at this. It's a 5, 12, 13 triple. If you didn't remember that, you could do some Pythag, right? You know, if you want to take your time, takes forever, 5 squared plus 12 squared, no hate on Pythag. But hey, man, we got those triples on lock. That's going to give me the square root of 169, which is 13. Okay? So Pythag's fine, especially if, like, they're not triples. But triples going to save you time. And we do a lot of triples. Triple here, triple there. Oh, my goodness, triples everywhere. All right. This is a Dr. Seuss book. I don't know. All right. Radius, 13, comma, theta, 247.38 degrees. Done. Dope. Hey, question for you guys. What if they wanted theta in radians? Anyone remember how to convert? Okay. You can multiply by pi over 180. So I'm going to put parentheses, pi over 180. So my radians then, I'd have this as my answer. I'll do it in a different color. 13. comma 4.3175, so 318. Boom. Just in case, man. You never know. They might ask you for radians. I don't know. Probably degrees. But anyways, just a fun little throwback to converting to radians from the good old days, right? Or maybe you hated it. I don't know. Either one. But there we go, guys. Found the angle of direction. Also polar form, which involves the angle of direction. Nice little, recap of some fun little math that you've done in the past. A lot of just stuff just keeps coming back as you go from, trig to polar to vectors and all that. So got to keep it all up in the brain scheme. All right. See you guys later.